Hello students, how are you all? I hope you are doing amazing. So welcome all of you at AriserTalent, and I'm your physics teacher Krina welcomes you all. So AriserTalent is actually an online learning platform where you can get your all the courses whatever you have desired for, whether it is for CBSE, NTSE, any of the JEE or NEET level exams you want for exams you want. So in this package, we generally provide a wide variety of courses to you. You have a solutions regarding your NCERT, you have a very good content for making the notes, and you also have a previous year exam solution for this. One more option we are providing here to you, that is our doubt panel. In our doubt panel, you can easily post your problem, whatever the problem you have, and our expert faculties will give you a solution of that particular problem you are facing. So just subscribe our channel, you will get whatever you needed, and basically what you have seen here, you will get a very good content from our expert team. We have an expert team for all the subjects, whether it may be maths, physics, chemistry and bio as well as. So subscribe our channel, go through each video lecture very clearly and keep in your mind a very clear picture of all the video lectures. So for this, you have to just subscribe our channel. So just subscribe our channel and enjoy our videos. So what we are discussed in our previous lecture, we are discussing about the magnetic effect of the electric current, and I know that in Fleming's left hand rule and right hand rule you have a bit confusion. Okay, ma'am, that what is the Fleming's left hand rule and how we will apply the Fleming's right hand rule. For solving this problem, we are doing some numerical problems here, so it may be clear picture in your mind that how you will apply this rule. So let's see every question very clearly and note down it, and if you have any confusion after this, then just post the questions to us. We will solve it for you and we are available to you anytime whenever you have a doubt in your mind. So let's begin with the first question we have. What your first question says that, think you are sitting in a chamber with your back to one wall. So I'm assuming that this is the wall I have and you are just sitting like this. You are sitting in a chamber with your back in one wall. An electron beam moving horizontally from back towards the front wall. So what actually happening here? You are just sitting with your back to the wall and an electron beam is coming from back to the front. It means electron beam is coming from back to front. It means the current will be going from front to back, because the current will also have a direction that is opposite to the electron beam will have. So I'm writing here, electron beam is coming from back to front. Electron beam is coming from back to front. Now, if electron beam is coming from back to front, what will be the direction of the current? The direction of the current will be from front to back. So, the direction of current will be front to back. I hope this is clear to you that how I have identified the direction of the current. Now, is deflected by a strong magnetic field to your right side, then what you have to determine? You have to determine the direction of the magnetic field in this case. So suppose if electron beam is coming from back to front, we are assuming that current is going from front to back. If current is going from front to back, it is saying that deflection of magnetic field is to your right. It means magnetic field deflection is in right. You have a induced current or induced force in the right side, but you have to determine the direction of magnetic field here. So what we have to determine? We have basically determining the direction of field. So direction of field you have to determine, and you have provided with the direction of force. Direction of force is in right. So these are actually the given conditions you are provided in the question. Now you have to identify the direction of magnetic field in this case. So what I will do? I will just apply the Fleming's left hand rule in this case. We have to apply the Fleming's left hand rule in this case. Now what Fleming's left hand rule states? Fleming's left hand rule states that your forefinger, thumb and middle finger, you have to stretch all these fingers in such a way that these are perpendicular to each other, and what you will get here, forefinger will give you the direction of field, middle finger will give you the direction of current, and the thumb will give you the direction of force. So these three things you have to kept in your mind, and I am writing it here because we will use them again and again in every question. So just copy this part from here. Now, what we are given? We are given that an electron beam is coming from back to front. Now, I have to assume that the current will be flowing from front to back because it will be the opposite to that of the current. So, I have to kept which finger is showing the direction of the current here. Our middle finger will view the direction of the current. So this is my middle finger and I am showing the current. That current is going from front to back. So what I have to do? I have to kept my middle finger towards the screen. So this middle finger is pointing towards the screen. It means current is going from front to back. So this will be the direction of the current we have. Now, if this will be the direction of my current, it is given that you are getting a force in the right side. So which will be my right side? I have my right side here. So the direction of the force will be like this. So I have to orient my left hand in such a fashion that this will be pointing towards the wall of the screen and this will be pointing towards the right. Now, this finger will give me the direction of the magnetic field, what I have to determine. So you can easily analyze that if this thumb will give you the direction of force and this middle finger will give you the direction of the current, this finger is pointing downwards. This finger is pointing vertically downwards. So I am getting the magnetic field which is vertically downward here. So you have to keep your hand in such a way that you will visualize it. So it will a bit difficult to show you here because the thumb, this finger is pointing inside. So you have to imagine yourself by visualizing this. So we will get the direction of the field vertically downwards in this case. So the answer will be vertically downwards. Is it all right? For such things, you have to assume your hand for doing all these questions. Now, we have many more questions here. Let's move to the next question we have. What the next question is saying? This is our next question. Now, an electron beam enters a magnetic field at a right angles as shown in figure. So just look at the question here. An electron beam is entering perpendicular here. So if electron beam is coming in this way, I can say that the direction of the current will be like this, because the direction of the current will always be opposite to that of the direction of the electron beam. So I can say that if electron beam is coming like this, the direction of current will be like this. So this will be the direction of current we have. It will be upward. Now, the direction of the force acting on the electron beam will be. Again, you have to determine the direction of force here. So again, we have to determine the direction of force. And you are given the direction of magnetic field this side. What is this side? This is our left, this is the left side we have, and this is the right side we have. So the direction of the magnetic field is in the left. So I can say that magnetic field is moving in the left side. Now, if I want to determine the direction of the force in this case, what I have to do? Again, I have to apply the Fleming's left hand rule. Now, we will do a quick revision again that what will be the fingers specified here. The forefinger will give you the direction of field, the middle finger will give you the direction of the current, and thumb will going to give you the direction of the force you want. Now, what will happen in this case? You can see here that electron beam is moving in upward direction. Electron beam is coming in the downward direction, and I am assuming that current is going in the upward direction. If current is going in the upward direction, which finger will going to specify the current? The middle finger will going to give me the direction of the current. So I can say that the middle finger is in the upward direction. If middle finger is in the upward direction, where is the current going? The current magnetic field is going like this. Magnetic field is going like this. Current this and magnetic field this. So I am drawing it like this. This will be our current direction. Current direction is upward and magnetic field direction, current direction is here and magnetic field direction is here. So this is what I get here. This is our current, this is our magnetic field. So I have to orient my hand in such a way that current will be in this direction and magnetic field will be in this direction, because this middle finger will give you the direction of current and this forefinger is giving you the direction of the field. So if it is like this, then according to the Fleming's left hand rule, what you are getting? You are getting the direction of the force, and the direction of the force will be coming out of the paper. It means it is coming out of the screen we have. So according to the Fleming's left hand rule, if I am assuming that this will be the orientation, you can see that these fingers are not mutually perpendicular to each other. So what I have to do? I have to just orient my fingers in such a way that I will get a proper direction here. So what I have to do? I have to keep the current in this direction. This is in this direction. So I have to keep my hand like this. If I make it to mutually perpendicular line. So this will be the direction of current. This will be the direction of magnetic field here. I have to orient my finger like this. Then you are getting here that the direction of the force will be into the page. So it will give you the correct direction if you orient like this. So it will be a bit difficult for me to orient the fingers like this. You have to visualize it with the help of your hand by using it in this fashion. So this will be my current, this will be my magnetic field, and this will be my direction of the force, and it is going inside the screen. So I can say that the correct option here will be into the page. So our option number C will be correct in this case. So I hope this problem has been clear to you. Now moving to the next part of the question I have. This is our next problem. The force experienced by a current carrying conductor placed in a magnetic field is largest when the angle between the conductor and magnetic field is. So it means you have to determine the force. It means when will be the force is maximum. So you have to identify the force will be maximum when. Maximum condition of force. Now, previously we have a discussion regarding a force on a current carrying conductor, and we have derived a very simple formula that F will be equal to BIL sin theta. Do you remember this formula? This is a very important formula you should keep in your mind for doing the numerical problems you have. So this will be the formula for calculating the force due to a current carrying conductor. Now you have to determine that when will be the value of force maximum here. So if I kept the value of theta equal to 90 degree, if I kept theta equal to 90 degree, sin 90 will give you the value 1. Sin 90 will give me the value 1. So F will be BIL sin 90 and F came out to be BIL. It came out to be BIL. So here I am getting the maximum value of the force here. So at theta equal to 90 degree, you will get the maximum value of the force, that will be your BIL. So let us check the options here. 45, 60, 90 and 180. So what will be the correct answer here? We will get the value at 90 particularly. So here option number C is the correct answer. Option C will be correct here. So just copy this part from here. So let us move to the next problem we have. The force exerted on a current carrying conductor wire placed in a magnetic field is 0 when the angle between the wire and direction of magnetic field is. Now again you have to determine the condition of force. So you have to identify when the force will be 0. So again we have a formula of force that is given by Bill sin theta. This is the formula for determining the force. Now, you have to determine at what condition this force will become 0. So, the sin theta will give you a 0 value only at sin 0 and when you have sin value that is equal to 180 degree. Because at particular value you will get a value 0. So, sin 0 will give you 0 and sin 180 will give you 0. So, from these options, if I substitute the value of sin here, and it means sin 180 will give you the 0 value. So, it means it will be F equal to BIL sin 180 and sin 180 will give you 0. So, we will get the force on a conductor equal to 0. It means when placed in a magnetic field, it will be 0 when angle between the wire and magnetic field is 180 degree. So, sin 180 I am getting 0. So, we are getting F equal to 0. So, the correct option here is option number D. If option 0 is provided here, then it will also be our correct option, but it is not provided here. So, you have to choose the angle 180 degree. So, this is again a very interesting question which is formula based we have. Now, let us move to the next part of the question we have. Again, it is a question that is based on the Fleming's left-hand rule we have. A horizontal wire carries a current as shown in figure between the magnetic north and south. You have to determine the direction of force on the wire. So, firstly, what we have to determine? We have to determine the direction of force. We have to determine the direction of the force. Now, the magnetic field lines, you can see here that they are moving from north to south. Magnetic field lines are moving from north to south. And you can see that the current is flowing in inwards. You can see that current is going from to inward of the screen. It is going from A to B and this is pointing inwards. So, we can say that current is pointing inwards. So, I can write here current is going from A to B and this direction is showing you inwards direction. This is our inward direction. So, if I am applying here the Fleming's left-hand rule, so I can say that magnetic field lines are coming from north to south and current is moving in the inward of the paper, or we can say that it is, in this case, it is flowing in inward of the screen. Now, according to the Fleming's left-hand rule, what we have to specify, again if I am applying the left-hand rule, so this thumb will give me the direction of force, this finger will give me the direction of field and this finger will give me the direction of the current. So, what will be the direction of current here? You can see here the direction of the current is inward. It means I have to keep the orientation of my finger in such a way that it is going into the screen. So, if the direction of the current is inward and magnetic field are coming from north to south means it is coming like this. It is coming like this, north to south. So it is bit difficult. You have to assume these conditions. Current is going inwards, middle finger is showing the current, and this forefinger will give you the direction of field, and it is coming from left to right. So this is the complete picture you are getting here. So this will be our current, this will the forefinger, and this will be the direction of the force. Now you can see easily where is the thumb pointing out. You can see that the thumb is pointing out upwards, so it is pointing out vertically upwards. So this is the complete picture we have. This is the forefinger giving the direction of magnetic field. This is my middle finger which is giving me the direction of current, and this is my thumb which is specifying the direction of the force which we have to determine. So the thumb is pointing in the vertically upward direction. So I can say that here the option number 4 is correct. Thumb will point vertically upward. So this is the solution of this problem you have. Just copy this part from here. So let's begin with the next problem we have in this sequence, and the next question you have is, this is the somewhat similar question we have discussed earlier. A current flows in a wire running between south and north pole of a magnet lying horizontally as shown in figure. The force on the wire due to magnet is directed. So again you have to find out the direction of force. What we have to determine? We have to determine the direction of force. And what we are given here, you can see that current is coming out of the screen. This is the direction of the current we have specified, and you can see that the current is coming from out of the screen. It means, or from the out of the paper you can assume. So I can say that if middle finger is giving me the direction of the current, it will be point outwards. So what you are given the direction of current, and the direction of current is outwards. Outward means it is out of the paper. Now, if I am talking about the direction of the magnetic field in this case, so you have to remember one point here, the direction of the magnetic field is always from north to south. So this will be the direction of the magnetic field I have. So the magnetic field will come from north to south. So I can say that magnetic field direction will be N to S. And according to it, the magnetic field direction will be from my left to right. So in this case, the magnetic field direction is left to right. Now, we have to again determine the direction of the force. So again, what we have to apply? We have to just apply the Fleming's left-hand rule again in this case. So what will be here? We are given a direction of the current. So the middle finger will give you the direction of current, the forefinger will going to give you the direction of magnetic field, and thumb will give you the direction of the force again in this case. So if I am assuming that current is coming out of the paper, if current is coming out of the paper, then this finger will specify the current. So I am assuming that this will be the direction of the current I have. It is coming out of the paper. And the magnetic field lines are going from north to south. So how could I twist this finger? I am showing this concept with my right hand here. So if we are assuming that the direction of the current is coming out of the paper, and the direction of the field is from north to south. Direction of field is from north to south, and the current direction is from out of the paper. Out of the paper means current direction of the current will be like this, and the magnetic field is going north to south. So this is a bit difficult to orient the fingers in such a fashion. So I am assuming like this. I am showing the concept like this, that the current is coming from outward the paper, magnetic field is showing from north to south. Is it clear? I hope this is clear to you, and these three lines are mutually perpendicular to each other. I am repeating once again, this will give me the direction of current, and the direction of current is outward the paper. This is giving the direction of field, and this field is from north to south. And what will be the thumb pointing out? You can easily visualize here that the thumb is pointing in the downwards direction. Thumb is pointing in the downward direction, or we can say it is in the south of the direction we have. So, if I am going to determine the direction of this force here, the direction came out to be downwards, and it will be our vertically downwards. So, here the options are from N to S, S to N, vertically downwards or vertically upwards. So, I cannot assume it as a south because the field lines are going from north to south. So, I have to say that the direction of the current will be in the downward only. So, here the option number 3 is correct, that is downward. So, the direction of force will be vertically downwards. Direction of force will be vertically downwards. So, this is again a very good question we have. So, just analyze this question very clearly by assuming your fingers here. Now, let us move to the next part of the question we have. Which way does the wire in the diagram tend to move? Now, what you have given? You have just given a magnet here having a north pole and south pole, and you are provided with the direction of the current. Now, you can see that the direction of the current is going from right to left. It is provided that the direction of the current is from right to left. So, what I have given? I have given the direction of current that is from right to left. Now, you can see that you are given the given conditions here. North and south pole are given, and you have to remind just one point, that the magnetic lines of the force or magnetic field lines always tends to move from north to south. So, this will be the direction of your magnetic field. So, we can say that magnetic field will be from N to S. And in this case, if it is coming N to S, it is coming downwards here. Magnetic field is downwards. Now, we have to determine where will the wire tend to move. It means you have to determine the motion of the wire in this case. So, if force is asked, induced EMF is asked, and motion of the wire is asked, we have the same solution, that thumb will give you the direction of the motion here. So, you have to determine, we have to find out direction of wire. And direction of wire basically means we have to find the motion here. And the analysis of the motion will be done only by using the thumb. So, the thumb will give you the direction of that motion. So, again, if I am going to apply the Fleming's left hand rule, what I have to do? I have to assume my left hand. Again, the thumb will give you the direction of motion, forefinger will give you the direction of field, and what will be the middle finger saying about? The middle finger says about the amount of current. Now, if the current is flowing from left to right, so what I have to do? I have to keep my middle finger like this. So, this is the picture I am getting here. Current is going from left to right, and this magnetic field is coming from north to south. So, what I have to do? I have to just orient this like this. Current is going from left to right, and magnetic field will be coming like this. Magnetic field is coming like this. Current is from left to right, and magnetic field is oriented in such a way that it will be going from north to south. Then, if I keep my fingers mutually perpendicular to each other, you can see that the motion of the wire it is showing will be in the upward direction. It means it is pointing towards upside. So, you can say that if current is flowing from left to right, if magnetic field is having a direction from north to south, the current will always point in the upward direction. So the current will going to be flow in upward direction. Current not, here the motion of the wire will be in upward direction. So we can say that motion of wire will be in upward direction. So again, this is a very good question you have, and I hope this topic has been cleared to you. So we have discussed a lot of problems today. So I guess Fleming's left hand rule is very much clear to you. So go through this video lecture so you can analyze by orienting your hand in this fashion, so you can get the idea about the direction of the field, current as well as the force. So this lecture is over here. So what you have to do, you have to just subscribe our channel to get the entire idea about this chapter. So in this chapter, we will basically cover all the contents and all the topics. You also have provided with the NCERT questions and the NTSE level stage 1 and stage 2 questions separately in our video lectures. But for this, you have to just subscribe our channel first. So this lecture is over here. Thank you so much. We will meet again with many more lectures like this. So have a nice day.